4-3, solving quadratic equations by factoring. And factoring is the key. We're going to spend most of the video talking about how to factor in all different ways. So let's start off. Factoring. So step one, this is always the first step, is you want to factor out a monomial. Factor out what they have in common. So when you factor out a monomial, you look at your terms and you see what they have in common. What could I divide both of them by? So in this case, I could divide both of these by 5 and an x. So you pull a 5x out. And what's going on when you factor is you divide by 5x. So you divide each of these by 5x. And that's going to be 7x. And that's going to be 3. Right? The x's go away. And that's how you factor. So 5x times 7x minus 3. Right, go to this one. And the only thing they have in common is an x. So you pull the x out. And you're dividing by x. You divide that by x, you just get 6. You divide that by x, you get 13x squared. And we go on to the next one. And look at all of these and try to see what they all have in common. I could divide them all by 3, because that's the smallest thing that they all have in common. And they all have an a, it looks like. So 3a. Right, and then you just divide each of these by 3a. And you get b minus 2c plus 3a minus 4z. And there you go. And I guess let's go tougher. So before we do that, I always like to do this first. If I gave you xw plus 3w, and I said factor, you're like, oh, they both have a w. It's going to be x plus 3. But look at this one. What do they both have in common? The y plus 2. So you pull it out, y plus 2. What's left over is x plus 3. Right, now notice now, a lot of people want to put y plus 2 squared because you have two of them. We don't do it up here. We don't do that up here, right? They both have an x. It's not x squared. They both have a w. It's not w squared. You pull it out. So when you distribute it back in, it works that way, right? If I distribute this, it would be x times y plus 2. And it would be 3 times y plus 2. Right? It works. So when you pull it out, they have it in common. Let's pull it out. There's only one of them. So let's bring that idea over here. Right, we look at this. They obviously all have n minus 3 in common. So you pull it out. I always like to cross it out so I know it's there. And what's left over is m squared plus m. Now right here, a lot of people want to put the 0. It's like stop. I'm like, no. Remember, you're dividing by it. When you divide something by itself, it's 1 minus 1. So don't forget that. So that's how you factor out a monomial, right? And that's always the first step. It makes your life so much easier. So see what they have in common, pull it out, and then divide by to see what's left over. So next one is my favorite one. We're going to factor by grouping. You do the same time you have 4 or more terms. If you have 4 more terms, we're going to factor by grouping. And all that entails is you want to group the first 2, the last 2. We always bring down the middle sign. So in the first 2 here, they both have a 3p squared in common. Right? And you divide by 3, you get 4p. Divide by 3, you get minus 7. Over here, they both have a 7 in common. And you get 4p minus 7. So first step is just split them basically, bring the middle term, factor out what each one have in common. And now look at, that's the exact same thing we did up here. Right, the exact same concepts. Like what do these have in common? They have a 4p minus 7s in common. So you pull that out. And look what's left over. 3p squared plus 7. That's the idea. Let's do some more. So this first one, let's group it like this. Alright, and first thing you notice is like these have nothing in common. These have a 3 in common, but they really have nothing in common. You can rearrange. So in that case, you want to rearrange it. So I want to get the MZs together. Or let's put, how do I want to do this? Let's see. Let's switch these two. I think that'll work. So it's going to be 9MZ plus 3MC negative 4NC. You negative 12nz. Right, so again, if you look at these, they had nothing in common. 4, no 9, like nothing worked. So I'm just going to switch these. And that negative goes with the 4. So you get that, and we'll group them. These have a 3 in common, and an m. And left with 3z plus c. Over here, now remember I said last time, always bring down the middle term. So that negative right there, you want to bring that down. These have a 4n in common. It's kind of hard to see. And then I get negative 4nz divided by negative 4 is this c. Negative 12nz divided by negative 4 is plus 3z. Now these look a little different. They're exactly the same, right? Remember, it doesn't matter how you add. So this is the same thing as saying 3z plus c because it's a positive. So these are actually the same. You can pull it out. And you're left with 3m minus 4. Factor by grouping. Alright, so we'll do a couple more. We'll skip one of these. A couple of these I want to hit though. So this one's an easy one, just make sure we got it. The last one's a little confusing. So factor everything out common, you go 4 and a b. Right, anytime you factor, just divide, so you get 3c, 4 negative d. Always bring down the middle sign. So it's a negative right there. Then these have a 5x in common. So 3c, now keep in mind you're dividing by negative 5x. Right, that's what's pulling out. So that becomes a positive 3c. And right here dividing by negative 5x. So it actually switches the sign. Negative d. And look what they have in common. 3c minus d. And you get 4b minus 5x. I want to go over one of those again. Just make sure we got that right. These have a 4v squared in common. Left with v minus 3. Bring down the middle sign. These have a 5 in common. Now again, look at it. You're dividing this by negative 5, so all you get to positive v. You're dividing 15 by negative 5, so you get a negative 3. That's how these match. So you get v minus 3. These are gone. 4v minus 5. Now the next one's super important. I like this one. So we're going to factor by grouping. So first thing you notice, oh, these have an 8r squared in common. Right? And what's left over is r minus 8. Over here, always bring that middle sign. These have nothing in common. So we're going to put a 1 on the outside. You can always factor out a 1. So if they have nothing in common, put a 1 on the outside. Now these match. You get r minus 8. And look what's left over. 8r squared plus 1. Very, very important, the plus 1. 8r squared would not be right. So that's the idea there. And so that's how you factor out grouping. Keep in mind if they have nothing in common to 1. So now we know how to factor out monomials. The first thing we look at. If there's 4 more terms, you factor by grouping. Next up, the beginning of every existence in Algebra 1, how to factor the number in front. So this is a fancy one. Now before I do that, let me go over like if you guys, most of you guys remember this from Algebra 1, the basic one where I give you something like this, minus 3x minus 10. Right? In this case, this basic way we did this. You figured out, you look at the last term, you go, okay, what are the factors of negative 10 that got me negative 3? So there's like negative 1 and 10, negative 10 and 1, negative 2 and 5, negative 5 and 2. In this case, this one would work. So my answer here would be x minus 5, x plus 2. Right, so that's how you factor when there's no number in front. And we're going to actually do more of those in a second. But I just want to go over that again because it's going to kind of make this part easier. So for this one, step 1, we're going to have space here. Step 1, gotta erase it. There we go. Step 1. So when you want to factor ax squared plus bx plus, I'm going to say step 1 one more time. Step 1, there we go, last time, I swear, is you multiply the first term and the last term. So if there's a number in front, you have to multiply these two terms. So you would multiply AC. So in this case, I'm going to multiply 6a squared and negative 7. I'm going to get negative 42a squared. Then we do what we always do. You multiply AC. We want to find combo, find factors of AC that multiply to get B. Right? So I want a combination of AC that multiplies to get B. So in this case, two things that multiply to get negative 4 are 2, but add to get 11. That's going to be negative 14A and 3A. Negative 14 times 3 is 42. Negative 14A plus 3A is negative 11A. Right? I know it has to be two different signs because it's a negative 42. And the middle one's negative, so that means the bigger number is negative. So that's all normal, right? Step 1, I should just make that all step 1. There you go, step 1. I know I've said it like 20 times. Multiply AC and find the factors of AC that multiply to get B. Step 2, this is a new part. You're going to sub the factors in for B. So that's a new step. So we're going to get the factors we just found, these two guys, and we're going to plug it in for B. Right? B is negative 11. This is negative 14A plus 3A. That's negative 11 also. So we're just going to plug it in. So it's going to look like this. 6A squared minus 14A plus 3A minus 7. So we're going to do that. We're going to sub in our factors. We're going to sub our factors in for B. So again, step 1, just multiply these A and C together. Then find the combination that gives you the middle. Step 2, plug that combination in for the middle. And then step 3, my favorite step, factor by grouping. Right, so there's only two new things. The first new thing is you multiply A and C. Right, so you multiply A and C. And then it's like always, find the combination that gives you the middle. Once you find that combination, we're just going to plug it in and factor by grouping. So by factors by grouping, these have a 2A in common. And you get 3A minus 7. Always bring down the middle sign. These have nothing in common, so remember we put a 1 on the outside. And then, hey, these match. So we get 3A minus 7, 2A plus 1. And that's how you factor the number front. That's the way that's the proper way of doing it. There's some shortcuts if you just look at the factors, but this is the proper way of doing it. So again, if you know how to do it, any way you know how to do it, it's great. But this is the way that always works, if it's possible to be factored. So let's do it again. Let's go on practice problem. So I'll multiply these together. Step 1. So I'm going to get 21A squared. And the combination gives me negative 10. So that's what? Negative 3 and 10. Negative 3A and negative 7A, I should say. Right, two negatives is positive, and then need to add to get a negative 10. So these two. Plug it in for the middle. So I'm going to get 3A squared minus 3A minus 7A plus 7. Then we just factor by grouping. These have 3A in common. So A minus 1's left over. Always bring down the middle sign. These have a 7 in common. That divided by negative 7 is a positive A. And then 7 divided by negative 7 is a negative 1. These match. So I get A minus 1, 3A minus 7. Alright? And that's the idea. I'm going to do a couple more, but it doesn't change. It's the same idea every single time. I have these. I'm like, okay, we'll apply these together. Negative 15p squared. Find the combo that gives the middle. So in this case, that'd be negative 5p and 3p. Plug it in for the middle. And then factor by grouping. So in this case, they have a p in common, and you get 3p minus 5. Always bring down the middle sign. These have nothing in common, so we put a 1 on the outside. P minus 5. 3p minus 5, sorry. These match. 3p minus 5, p plus 1. And by the way, it doesn't matter if you flip these, it still factors perfectly. Like if I would have put this one in front first, I would have got 3p squared plus 3p, sorry, minus 5p minus 5. Right, if I just switched them, these factor 3p, p plus 1. Always bring down the middle sign. These have a 5 in common. P plus 1. These factor. P plus 1. 3p minus 5, right? The exact same thing. Doesn't matter which way you do it, you get the exact same answer. So that's the idea of how you do it. I'm going to skip a couple of these because we've done a lot. I'm going to get to this one. So this one looks disgusting. You're like, oh, I do not want to multiply 45 times 18. Yes, you don't. But don't forget rule 1. Factor out a monomial. So if you have a chance, you want to factor out a monomial. So in this case, these all have a 9k in common. I can divide them all by 9k. So if you divide that by 9k, you get 5b squared. That you get 7b. And over there you get 2. Right, so you get something like this. Now it's a lot easier. I'm still not done. I still got to factor it, but so much easier than factoring this thing out. I'm going to multiply my terms together. I get 10b squared. Figure combination gives you the middle. So in this case, negative 2b and negative 5b. Those two things multiply to get 10, but I have to get negative 7. Plug it in for the middle. Factor out what they have in common. These have a b in common. So I get 5b minus 2. Bring down the middle sign. They have nothing in common, so pull out a 1. Negative 5b minus the negative 1 is 5b. And then 2 divided by negative 1 is a negative 2. Hey, these match. And you get 5b minus 2, b minus 1. And don't forget about the 9k on the outside. Right, so all the same rules apply. Just don't forget rule number 1, factor out monomial. Make your life a lot easier. If you can do it, makes your life a lot easier. Okay, so how do you do it without number front? We talked about this earlier. Without number front, you can still do it the same way. I'll actually do it the same way. Let's do this first. So if you like that method, it still works. I wouldn't recommend doing it because it takes forever. In this case, it takes forever in retrospect, but same rule applies. 90a squared, I need two things that multiply to get 60, but add to get 17. So that is 12a and 5a. That's the hardest part, by the way. For me, the hardest part of doing this is trying to figure out the combination. So 12a and 5a. 12 times 5 is 60. 12 plus 5 is 17. Plug it in from the middle. I'm going to get a squared plus 12a plus 5a plus 60. These have a in common. So a squared plus 12. Bring down the middle sign. These have a 5 in common. Sorry, a plus 12. Then I get a plus 12. These match. A plus 12. A plus 5. So it still works. That's the proper way of doing it. So it still works. But on here, I definitely would just do the shortcut. Right? If there's no number up front, then we can just do a shortcut where all we do is look at the last term. We know it has to be a and a. So all we do is look at the last term, figure out two things that multiply to get 60, but add to get 17, and that is 12 and 5. They're both positive, so a plus 12, a plus 5. So again, that's what I would do because it saves you probably about 30 seconds. And it's just the easiest way of doing it. So no number front, just do the easy way. So if I was doing this one, I just go, okay, it has to be an x. Has to be an x. Try to find two things that multiply to get 32, but add to get 12. So they'd be different signs that work against each other. Ooh, I mean, sorry, that'd be the same sign. It's positive 32 and negative 12, so negative 8 and negative 4. Done. Right, and then so on, so on. This is an x. It's a negative 21, so it means that they'd be different signs. So here's a little trick, right? So we know if it's positive, same sign. It has to be both negative. Sorry, it has to be the same sign. It has to be the same sign. If it's negative, that'd be different signs. So I need two things that multiply to get 21, but add to get 4. So that's 3 and 7. Right. How do you know which one's negative? Look at the middle one. Whatever that has to be this is the bigger number. So in this case, I know 7 has to be negative. Because negative 7 plus 3 give me negative 4. Right, so different signs. How do you know which one the bigger number is? Let's look at the middle one. That's always a bigger number. The sign of the bigger number. Anyway, so that's how you factor. The basic ones. You said go different to two squares. The last type of factoring for now. So very famous formula. A squared minus b squared is a minus b, a plus b. So all that says, hey, if you have two squares, like x squared and 25 is 5 squared, we know it has to be x minus 5, x plus 5. Works here, this is 7 squared, so this is going to be 7 minus w, 7 plus w. Now remember, it only works when it's a negative sign. If I gave you x squared plus 25, that cannot factor. Has to be negative. So we call this prime. Just like in normal numbers. If you can't factor, it's prime. Over here, that is square root of 625 is 25 minus y. 25 plus y. Even works when there's numbers in front. This is 12 squared and this is 7m squared. So 12 minus 7m, 12 plus 7m. Works when there's fractions. Square root of that is going to be 4 over 5. So m minus 4 over 5, m plus 4 over 5. Right, different two squares. Only works when there's two things and they're both squared. This follows the same rule too. Hey, that's a square. I can square root that, and that's 6 squared. So this is going to be the square root of that, which is this a minus 5 plus 6, and a minus 5 minus 6. Or if you want to go further, a plus 1, a minus 11. Right, and the same thing here. Hey, they're both squares, so square root of that's just k plus 4 minus parentheses square root of that k minus m, and over here k plus 4 plus parentheses k minus m. So that's the difference of two squares. Right, again, cannot stress enough. Both have to be squared and it has to be a negative in between them. So that's factoring. That's how we factor. But we're not done. That was factoring. Now we got to solve by factoring. Okay, so first thing we got to do is solve about the zero product property. Super important property, makes life easy if you follow it. So zero product property says this. If you have x minus 3 times x plus 2 equals 0. Well, for this to be true, all you gotta do is set one of them equal to, set either one equal to 0, right? So if this is 0, let's set x minus 3 equal to 0. Solve it, x equals 3. This works. I mean, that's how you do it. Just split it and solve each one separately. Why does this work? Because if you plug it back in, let's say we plug that back in, I get 0 times negative 5. Well, 0 times negative 5 is 0, so it checks out. This only works when you set it equal to 0. So I cannot stress that enough. You have to set it equal to 0. People try to do this for everything. They try to do this. Like, oh, we'll set it equal to 5. We'll just separate and go, hey, where does x minus 3 equals 5? X equals 8. It doesn't work, because when you plug it back in, I get 5 here, but over here I get 10 and I get 50. It's not 5. It only works when you set it equal to 0, because 0 automatically makes it work. So I cannot say that enough. Set it equal to 0. If I had stars or something, I would do that, but I have a highlighter. Boom. Set equal to 0 first. So that's going to be step 1. Set equal to 0. And then we're going to factor. And then we're going to split and solve. So step 1, right? See, now it's already factored for us. It's already set equals 0. So all we got to do is split and solve. X minus 3 equals 0. X plus 1 equals 0. Add 3 to both sides. X equals 3. Subtract 1 from both sides. X equals negative 1. Over here, it's still factored, so we split it. 4a equals 0. A plus 2 equals 0. People freak out on this side. Why? Just divide by 4. Hey, a equals 0. That's fine. That's an answer. And a equals negative 2. Right, so we're going to set equal to 0 and then we're going to factor. Moving on. So this one's not factored for us. It is set equal to 0 though. So all we got to do is factor this. Now, don't overthink it. There's only two things here and it's not different two squares. So remember step 1. Monomial. Factor out monomial. These both have a 6x in common. So now it's factored. Now you split it. 6x equals 0. Divide by 6. X equals 0. It's a fine answer. 2x minus 3 equals 0. Plus 3 plus 3. 2x equals 3. X equals 3 halves. So those are my two answers. Over here, notice it's not set equal to 0 first. So step 1, set equal to 0. So x, so let's subtract x from both sides. I like to put it down in order. So x squared minus x minus 12 equals 0. Now we got to factor it. In this case, it's an easy one. All I gotta look at is negative 12. Two things that multiply to get negative 12, but add to get negative x. So negative 1. So x minus 4, x plus 3. Then you can split and solve x equals 4 and negative 3. A couple more. So this first one here. Remember I say it's always set equal to 0, and I always say 7 or 1 to monomial. Well, in this case, since you're solving, only because you're solving, you can actually divide by the monomial. Let's divide everything by 2. And then we'll get 6x squared minus x minus 1 equals 0. Right? That makes our life easier. I still got to solve the same way. I got to factor it and set equal to 0. This factoring has a number in front, so we got to do the long way. So minus 6x squared. Find two things that multiply to get negative 6, but add to get negative 1. Negative 3x and positive 2x. Plug it in for the middle. So we're going to have this. So that's how we factor with the number in front. We multiply the a and c. And then we figure out the combination that gives us the middle, plug it in for the middle, and then we factor by grouping. Favorite type of factoring. These have a 3x in common. 2x minus 1. Bring down the middle sign. These have nothing in common, so remember, always pull out a 1. Split. Factor out what they have in common, 3x plus 1 equals 0. So we factor it, and now we split it, solve each one separately. Add 1, divide by 2. Subtract 1, divide by 3. And there you go. Alright, so that's the way it works. It's all about set equal to 0, factor it any way you know how to factor, and then split and solve. Got one more of these. Try to do this one quick. Again, set equal to 0. So it's going to be 2x squared minus 24x squared plus 72. Right, we're going to add 72 to both sides. Equals 0. Now here, again, notice they're all even. I can divide by 2, make my life a lot easier. If you do whatever you do, once I get to the other side, so I can divide 0 by 2 also. I get x squared minus 12x plus 36 equals 0. Factor it. That's x minus 6, x minus 6. So I get x equals 6, and what that means? I have a double root. Boom. Right? You only have one answer twice, double root. So this graph, I know it's going to look like the ones where it hits and it bounces. By the way, where does it hit at? 6. Whole point of that. Right? Like the one right here. I could graph this. It crosses at negative 3. Right? That's what x-intercept is. And it crosses at 4. It opens up because it's positive. So if you know the x-intercept, you can graph it really easily. So that's how you solve. Last couple things, so how to go backwards. So first, we know how to distribute, right? If I give you this way and you want to distribute, just go like multiply the x by both of them. So x times x is x squared. X times 5 is 5x. And then we move on to negative 3. And multiply that by both of them. So I get negative 3x, negative 15. Add like terms. That's the easiest way to distribute, right? Some junior high people tell you to FOIL. That is awful. Just distribute. Right? If I have this, all I gotta do is get 2x, multiply by both of them. How hard is that? Seems simple enough. And then you move on to the next one. Hey, there's another number there. I should probably do the same thing with that thing. Multiply that by both of them. Negative 10x plus 15. Add the like terms. So easy, and we are done with that. Okay, now let's go backwards. So, kind of like I talked about earlier, if I gave you this, right, we knew the answers are just opposite. If I gave you x minus 3x plus 1, the answers were 3 and negative 1. What if I give you the answers, though? Right, if these are the answers, they want to know what's the equation. We just go backwards. That's supposed to be an arrow. That's also supposed to be an arrow. Hey, it's getting a little better now. There we go. Now it's kind of like an arrow. So we do the opposite. X minus 8 has to be x plus 8. X plus 5 has to be x minus 5 equal to 0. Right? So because if I solve this, I get x negative 8 and I get 5. Now they want in standard form. Standard form is where you just have ax squared plus bx plus c. So what we do next, we distribute. So that's why we know to right here. So multiply the x by both of them, x squared minus 5x. Multiply 8 by both of them, you get positive 8x minus 40. So you get x squared plus 3x minus 40. So that's how, if I give you an answer, how do you write an equation in standard form? You do the opposite, and then from there you could simplify it out. Then now you're looking at it like, oh, what do I do if it's ugly fractions? Do the exact same thing. Minus 3/2 x minus 1/4 equals 0. Now you can multiply it out. It's not that hard. It looks worse than it is. X squared minus 1/4 x plus 3/2 negative 3/2, and then plus, remember multiply, just multiply across, so 3 over 8 equals 0. So you get that, and you're like, that looks ugly. Well, you're right. We can make it a little nicer though, right? If you want to get rid of all the fractions, remember all we do is multiply by the greatest common factor, which is 8. Right, that's the biggest denominator we have, the LCD of all this. So you multiply this by everything, you get 8x squared minus 2x, 8 divided by 4, 4 times 3 is 12, 8 cancel out, plus 3 equals 0, then add up like terms. So there you go. So, right, if we give you this, it's the exact same thing. Like, this is a fine answer. Like, there's nothing wrong with that. You could stop there. But if you want it to be nicer, multiply everything by the LCD. One last one, and then we're done. I promise you. So here's this one. Find x and dimensions of each rectangle. So they want me to find dimensions of this rectangle. Well, they tell you the area is 96. Remember the way you find area of a rectangle? Length times width. And I have everything I need. Area is 96. The length is x minus 2. The width is x plus 2. Well, we can multiply this out. I get 96 equals x squared minus 4. Right, it's a difference of two squares. So you can do the whole thing if you want. But it's a difference of two squares, so you should know automatically that's x squared minus 4, because the middle's going to cancel out. So we get down to here, and this is actually something I want to bring up. So before I start solving this, this is a very important concept. So for quadratics, if there's one variable, like we have right here, just solve. That's the easiest way to do it. So if I give you like 3x squared plus 4 equals negative 5 or something, you just solve it. Just solve for the x, try to isolate the variable. If there's two variables, like 3x squared plus 2x minus 1 equals 15, then you have to set equal to 0 and factor. Now this way it still works. I'm actually doing this one both ways. But the easiest way to do it when you have one variable is just solve for it. Like, oh, I have an x squared here, just try to get that by itself. Plus 4 plus 4. I get 100 equals x squared, square root it. X equals plus and minus 10. Don't forget the plus minus, we square rooted it. That's what x would be. That's one way to do it. Other way to do it is you can still do it this way, right? Set equal to 0. So if I set equal to 0, subtract 96. I get 0 equals x squared minus 100. Then you can factor the difference of two squares. Split it, x equals 10 and negative 10. So they both work. You get the exact same answer. Generally, the easiest way to do it if you have one variable is just to solve it. Just try to isolate it and solve. If there's two variables, you have to set equal to 0 and factor. Just have to. And that's the idea.